Okay, so number 13. Two blocks are joined by a light string that passes over a pulley as shown above, which has a radius r, moment of inertia I about its center, T1 and T2 are tensions in the string on either side of the pulley, and alpha is the angular acceleration of the pulley. Which of the following equations best describes the pulley's rotational motion during the time the blocks accelerate? Okay, and so if you look at these examples, they're really asking us to set up a torque net for this pulley. Okay, so for this rotating disc, right? A pulley is just a rotating disc. Okay, and so for something like that, my torque net is equal to, well, I'm going to have two torques, right? So I'm going to have a torque 1. Well, let me rewrite that. Okay, before I write, I know I have two torques, right? But I'm going to have this one and this one. Now, which one needs to be bigger, right? Because I need it to, it's going to end up rotating in this direction, right? As this M2 block goes down. So I know that the T2 torque has to be the bigger torque. So I'm going to have that as my positive torque. So I always want to set my direction of acceleration or angular acceleration as positive. Okay, so I'll have torque 2 minus torque 1. Okay, now I just need to plug in for my torque net, so that would be I alpha is equal to, well, my torque 2, remember torque is equal to RF, okay, so I'll just have R times my F, which is just T2, right, and then I'll minus R, same R, minus T1, okay, and so all I need to do to make this look more similar to the answer choices is to I alpha equals R, so I'll factor out R, T2 minus T1, okay? And so that would mean that my correct answer is just D.